What's up, YouTube? Hope you're doing well. I've been doing well. I know it's been a little while since I've made video, but I got a bunch of free time, and so here I am. I want to show you guys how to use this module script that I created for creating non-humanoid animations and or animations for works for humanoids too, but it could also be for bigger things. Roblox's current animation system, I haven't really figured out how to get to work with, you know, like non-humanoid stuff or humanoids that have a bigger size, such as our friend over here. This animation module will work on him, where, as far as I know, the like this animation editor here. Oh, can't be used while the game is running. Your usual Roblox animation plugin thing uh, doesn't quite work with this stuff, or at least I can't figure out how to get it to work. So I made my own, um, and it's very cool. So I'll show you how to use this, and well, I'll start with showing you this little script here. So it's this simple. This is how simple it is to make it work. Um, the module's right here. If you look on the right in the workspace over here, I've got it in replicate storage in a folder called modules, servo animation. And we'll get into the guts of that in a minute, but the idea is that you don't have to worry about this thing. Just know what it can do, and I'll have this video to explain how to use it, as well as some written instructions to go along with it. But back to this doodad script. Alright, so I just have a script inside this doodad here. The script is called doodad. The first thing you do is just require the module, of course. And also inside the doodad, I have another module script called animations. And basically it contains a table of the animations. And it only has one animation right now. It's called do stuff, the do stuff animation. So we're here in the animations module right now. So basically, if you require the module, it will just return whatever animations that you have in here. And you can kind of see here how it's set up, but I'll go into more detail here in a second. If we go back to our doodad script, which is just this script inside our doodad, what it does is, as you can see, requires the animations module. And this is where it gets interesting. So if you want to be able to play animations with the animation module, you declare a variable and say that the rig, you can call it whatever, but I like to call it a rig. So rig equals SAM, this stands for servo animation module, dot rig, and then you pass in the model that you want to animate. And so then after a second here, it will play the do stuff animation, and this true means that it will loop. So if we run, it's just going to loop through the do stuff animation over and over again. So let's take a look at the actual animation. Essentially, oh, and also we'll get to this in a minute, but you need to be able to build your rig or your model in a certain way. Notice I have here a part C, a part H, and a part P. What that stands for is cylindrical constraint, hinge constraint, and prismatic constraint. So this servo animation module that we're using supports those three types of constraints in our models, in our rigs. Okay, so you need to name the part, whatever you're gonna want to, however you're gonna want to use it in when you're typing up your animations. So back to the animations. It's done in frames. So, by the way, hopefully you have some knowledge on module scripts. This isn't a module script tutorial, so hopefully you know how to use those. If you don't, go research it. But essentially, requiring a module using the require method on a module will return whatever this module returns, right? Okay, so inside here we have the do stuff animation. And each of these are frames in the animation. So what it's going to do is when we play the animation, it's going to go through each of these frames. Now, each frame needs to have a speed, a duration, and then a moves table. So the speed, what that does is it changes the speed at which the constraints will run inside inside this frame. So if we were to let's run this so you can look again. So you can see kind of how there it's kind of slow. Parts are moving a little bit slow. But if we were to up the speed on this to say 8, so you can get a drastic difference. So I'm changing each of the frames. I'm gonna make them all faster, and we run it again. Oh, we're getting a little lag here. There we go. You can see things are moving a bit quicker now. And that's because I upped the speed. And the duration is how long the frame takes, of course. So if your speed is too high, then your parts are going to reach the places that they're meant to go to, or they're going to achieve the angle that you've told them to go to before the duration is over, and sometimes that's what you want. And so you just need to fine tune it a little bit, get the duration and your speed right, so it can be how you like it. Now in the moves, this is the important part. This is how we tell the constraints to move around. So here we have H for hinge constraint. So we're saying, all right, H is 45 degrees. And then P, which is our prismatic constraint, we're going to say 5, which basically changes its target position to 5. And by the way, I also recommend familiarizing yourself with these 3 types of constraints. And then C is a little bit weird because cylindrical constraints have multiple different dimensions, I guess you could say. A cylindrical constraint is basically a hinge constraint and a prismatic constraint put together. So I'll kind of show you here what I mean. So this green block here is a prismatic constraint. It doesn't have any rotation. It's just attached to this block, but it does have like a distance. It's kind of like a piston or a rod. You can think about it attached to that part. But a cylindrical constraint also has rotation, as you can see. And so if we go back to our animations here, if you want to change a cylindrical constraint, then you need to say the C equals a table. You pass in a table, and then you can change whatever properties that you want inside the cylindrical constraint. You can even change the angular speed, and this actually is programmed to do anything. So this will change any kind of property that you want to within the cylindrical constraint. However, I recommend only using target angle and target position, I believe. Those are the important ones that you want to use. And if you want to, you could also do the speed, which is just the speed at which it let's say speed is 2. That's just the speed at which it extends out from the part that it's attached to. Okay. So because I set that speed to 2, we'll notice that on this first frame it's a lot slower now, right? And then the second frame is bigger. So essentially that overwrites the frame speed that you've given it. All right, so maybe let's take a little break here. We've said a lot. There's a lot of information here. So let's just take a break and think about that. Yeah. All right, so here we are back. So yeah, I recommend maybe trying this out a little bit at this point. I'll probably include a model to this sample doodad, so you can take a look at how it's working. Yeah, let's continue the explanation. So I've created a simpler doodad that only has hinges to use. So now when you're setting up a doodad, you need each of the constraints that you use. So let's look at this hinge constraint that I've put on here. The actuator type. So you need to have an actuator type and set that to servo because that's how this works. And so you don't need to change anything except for the servo max torque. Make sure it's something other than 0. 400,000 seems to be pretty good. Just give it a nice. The number is going to need to be bigger depending on how big the part is. But 400,000 seems to work pretty good. Or maybe that's 4 million. It's 6 zeros. It's probably, that's a million. Yeah. All right. So now we've set the actuator type to servo and the servo max torque to 4 million. I've also edited the little animation for this one. So let's go ahead and run it, see if it works. Right on. Okay. So let's take one more look at this animations here, and then we'll go into some other sort of, I guess you could say, advanced stuff. So in this simple doodad, look at the animations. And you can also see that I've changed these parts here to be H1 and H2. So the first thing it does in this first frame, it's got a speed of 1, duration of 3. It's going to set H1's angle to 45. H2's angle is going to be 180, which you can see right off the bat. So this thing turns all the way around, it's like 180 degrees, and that just does a 45-degree angle for the first frame. The second frame changes the H1, which is the yellow part, to 180, right? And it doesn't do anything with the pink one, the pink block. And if you don't do anything with any of the parts in one of the frames, then it's just going to leave it alone. It's not going to set it back to 0 or anything. So you can take advantage of that as you build your animations. And then for the third frame, just returns everything back to where it started. Okay, so let's show you one more thing here. Right, so this script is the same as that one, but you can do some really cool stuff. So we'll call this doodad, doodad2. Doodad2. Okay. In our simpler doodad, let's go to the animations in our simpler doodad. You can do something cool, and I'll show you. Let's say, and we need a comma here, post func equals function. We're gonna say, oh, hold on a second. Right, okay. We're gonna say script dot parent dot h2 dot brick color equals brick color dot blue. Let's make it blue. And okay, so what this does is at the end of this frame, it's gonna run this function, right? So let's go ahead and run it. Oh, we got a little error here. Huh? I must have looked in the wrong animations. Doodad2. What did I do? That's kind of weird. We need to put that over here. Okay, that should do it. Aha, here we go. Alright, so once this is done, boom, turns blue. Pretty cool, right? So, in your animations, you can add functions that do whatever. We could even, so there's a post func, and why it's post func means it happens at the end. So now, but what if we want it to happen at the beginning? Pre func equals function script.parent.h2.brickcolor equals brickcolor dot, is there pink? There's no pink. Dot new pink. What's a good pink? Hey, pink. Yeah, just pink. Pink. It's gonna be a little bit brighter than our starting pink, but it's okay. And don't forget the end and a comma. Now this pre-func can or post-func, doesn't matter where you put it in the frame, it just needs to be there. But I like to have my pre-func at the beginning because it happens at the beginning. So let's go ahead and run this again. So that's gonna turn blue. And that does a thing, and now it turns back to pink. Alright, cool. A little bit brighter than starting pink, but you know, makes sense. Okay, and it's just gonna keep looping through that. So that's another trick you can do with this. So now, let's let me think. How about this? Let's build one from scratch. First I will show you the animation or the module. Okay, so first thing that you're going to want to do if you want to use my module is get the module. I'll have a link in the description. And you're going to want to put it wherever you like to put your modules. I like to put my modules in a folder in the replicated storage. So for me, I've got the module right here. Now you shouldn't have to do anything here, but I guess it can kind of explain how it works. Essentially, when you call the rig, when you call the module.rig, it returns a table containing some functions and some stuff, and I won't go too far into it. But essentially, when you tell it to play an animation, it goes through each of the it scans the rig, the model that you passed in. It scans the model for all the proper constraints, and it keeps track of all those constraints. And so then when you tell it to play an animation, it knows easily what you mean when you say H1. So if we go back over here to the animations, it knows what you mean when you say H1 equals 180 because it's scanned it. It's gone through and it's seen that a part named H1 has a hinge constraint. And so it's going to add the H1 to the rig and it's going to know what you're talking about. But yeah, and then it goes through each of the frames, and for each frame it adjusts the properties for each constraint according to what you've told it to do. But yeah, again, you don't have to worry about that. This is just kind of something if you kind of want to have an idea of how it works. So now let's build something from scratch so that you can kind of have an idea for what we're going for. So let's, oops, no, we just want this part to be in the workspace. Thank you. Thank you. All right, so we have a part here. Let's make it anchored. We're going to make it kind of like those. Suspend it in the air a little bit. Duplicate it, create another one. And this will be our little hinge constraint. And let's make it a blue. It is a baby blue color. And let's go ahead and just make it a couple studs. Right here. Okay, we're gonna have a little animation that just turns this thing back and forth. So if you've ever put some hinges together, right, you go to create hinge. I've already got it set there. I'm gonna put the hinge here, here, and now I'm gonna move the part back down. All right. So now it's attached to the part. Did I unanchor this? All right, this blue block needs to be unanchored. All right, now let's name this part H1 because that's kind of what we did before. And let's group these together. And we'll call it super simple doodad. All right, now I just need a script to get it running. We'll call the script super simple doodad. All right, and before you write that script, of course, we need our animations. And you could have multiple, you could have a module script for each animation, or um, you could have a single module that holds all your animations. It's kind of what I like to do. Let's, yeah, let's just say animations. Let's do it how we've been doing. All right. So let's just have 2 frames. So we're gonna have our first frame. Oh, module. My bad. So before you do frames, you first need to say the animation. So do stuff. So we'll have 2 animations in this for our guy here. So we'll have do stuff. All right. So now we have this is our animation. Boom. Let's create a frame here. Remember, we need a speed. Let's say speed is 2. Speed equals 2, comma, duration equals 2. Moves equals, and this is where we put our stuff, and we'll just say that h1 equals 90, say 90 degrees. And instead of having it go back, let's have a separate animation. Module dot go back equals, and then we'll have speed equals, let's make it 3, and then duration is going to be, probably just needs to be, we'll make it 2, and then moves equals h1 equals 0, putting it back to nothing. Alright, so there's our animations right there. So now we just, well, that's kind of weird, my headset cut out there for a second. My apologies. Alright, so, what is it, control 0? Okay. Here's our script for our super simple doodad. So we're going to say local SAM equals game.replicate storage modules servo animation, and I always forget to require. Am I recording? Yep, I'm recording. All right. And then we also need the animations. Local anims equals require script dot parent dot animations, and now we just say sam.rig script.parent. We're just passing in the model here. And of course we need a variable, so we're going to say local rig equals that. So now we can say rig.play, and instead of looping this, we can just say anims.dostuff. Alright, so let's go ahead and run that. Now it's not working for some reason. And let me check this out. Aha, see, so I forgot to change our hinge constraint to be a servo. So it needs to be a servo, it needs to set our max torque to 4 million. And let's try again. There we go. Alright, so you can see, as you can see, it played the animation, changed it to 90 degrees. Now remember, we have our other animation, which is go back. So what if we play that and then wait for 1 second and say rig.play go anims.go back. There we go. And let's give us a little wait here so that we can get in before it loads. There we go. Boom. All right, then it says go back. Okay, so that is pretty much how you use the servo animation system. Maybe I can make a part 2 for some other stuff, like how I created our gargantuan Fred here and made him walk, because it's quite a bit complicated, so best suited for maybe another video or something. But yeah, that is how you use this. There is one more thing to mention, and that is, other than play, the rig object has something called stiff, rig.stiff. And what that does is it basically just resets all of the constraints to 0. So instead of having this go back animation to set it to 0, we could just get rid of it altogether and say to rig.stiff. And if you want to change the speed for how quickly it stiffs up, you can pass in a little number here. So you can stiff at a speed of 5, and it's going to do the exact same thing as turning it back. And we've got a little error here. What did I do? Let me look at this. Okay, I fixed it. There was just a little problem in the module script here that I fixed. But yeah, so if we run it, boom, boom, and it goes straight back. And that's because you did the stiff at a speed of 5, and we could do it at 10,000 or something, and it'd be really fast. Oops, I think we need to, yeah, all right. Boom, and it just instantly goes back. All right. Anyway, so hopefully this has been helpful. I know it's a very difficult module for me to explain just because there's so much to it. But leave any comments or leave any questions in the comments below, of course. And yeah, so hope you enjoy and have a good day. Thank you. Goodbye.